Hello everyone and welcome back. Today I'm gonna talk about the power of physics, the power of the dark side of the force has many abilities, some considered to be unnatural. This is the quote from Star Wars. This is the quote of Darth Sidious, a masterful manipulator who is the master of the force. Physics, like the force in Star Wars, can help you to do extraordinary things. You see, physics isn't a body of knowledge, it's a way of seeing and perceiving the universe and the things in it. And you do it using mathematics, you do it analytically. And this is the most beautiful aspect of physics. The most beautiful aspect is to come up with new ideas and see the connections where other disciplines fail. And this connections actually doesn't come up from the stubbornness of physics. It's actually the quite opposite. It comes from the open-mindedness of physics. It comes from by asking questions and being humble. Because you need to be humble and open-minded. You need to be able to change your perspectives, the way of attacking to problems constantly. This is how you can solve hard physical problems. You need to be the most critical person while working on physics or any other problems that you are trying to solve. You need to be the most fearsome critic of your own work. But the power of physics is actually can be perceived with a very beautiful example by Fermi. Enrico Fermi, a brilliant Italian physicist who is one of the fathers of atomic bomb actually. He was, I think, at the University of Chicago, one of the guys who experimentally demonstrated the fusion reaction. And he actually was the one with his group in Italy for the first time to show that fusion was possible, and because of the Second World War he had to flee to United States. Then of course, famously under Oppenheimer, they developed the atom bomb. But there's a legend, a myth of Fermi. When the bomb exploded, it was said that Fermi was able to calculate the power of the bomb just by looking at how the papers on the floor fluctuated because of the explosion. It's an incredible thing to do when you think about it. Because when other people outside of physics look into the field, they think that physics, it needs to be exact, it needs to be certain. There isn't any approximations in physics. It isn't a statistical field when you, of course, outside of the fundamental disciplines that use statistics intrinsically, it is an exact science. This is what we look in physics. But approximations and guesses and tricks, which is encapsulated beautifully in the example of Fermi, and of course with Feynman as well, the most joyful physicist among all. He loved to play with numbers, he loved to come up with tricks, and one of those tricks is Feynman's diagrams, to show and demonstrate and to find a shortcut for QFT calculations, an alternative to Schrodinger's quantum field theory. So tricks are powerful. And Fermi's method can be used to other problems anyway. For example, one of my friends were applying to a company in Turkey. It was I think an economics company, and one of the interviewers asked, please guess me, how many pharmacies are there in the whole country? And the way to do that, I was able to answer the question within, I think, 2% or 3%. And the way to do that, like many other problems in physics, like how Fermi did it or how Feynman did it, you need to be able to go to the most fundamental aspect of that problem. You need to find the building blocks of that problem. If you find the building blocks of the problem, then the next step is find the connections of those building blocks. And then from those connections, you will build up your solution. So the way to approach, for example, for the power of the atomic bomb, first, you need to understand, you need to guess the correlation between, for example, the inclination of those papers with the power of the explosion. And how can you do that? You need to have an account for the velocity of the wind and its connection to the power of the bomb. And the power of the bomb, yeah. So, and you can approximate the power of the bomb, for example, to the amount of the collisions of the uranium atom, for example. So, you see what I'm trying to do? It's like the chain expressions in calculus. You basically need to divide your expression, the problem, into sub-problems, and in the end you need to multiply them. And that's also what Feynman did. QED is a very hard discipline. It's the hardest in physics. I mean, I'm not counting string theory. So, Schwinger, a brilliant mathematician and physicist, though, he was a brilliant analytic calculator. I mean, he was able to come up with equations misfully. His mathematical intuition was more powerful for him than his physical intuition. So there are two types of physicists, if I want to explain you what I try to mean. One of them, for example, people like Feynman and Einstein and Faraday, most famously, that started them all, the thought experimentalist guys, who are closer to physical intuition. But there are physicists like Schwinger, Witten today, who are mathematically minded. They approach the problems mathematically. And Schwinger was one of the guys. But Fermi and Feynman, these guys were intuitive thinkers. So what Feynman did is similar to Fermi. Fermi is approximation. Okay, mathematically we can do some analytical calculations, all right. But I'm a trickster. I want to do it like nobody else. I'm a bit of a narcissist. Of course, I'm quoting Feynman. So I need to be able to think this faster than anyone. Then let's go into the most fundamental aspect of the problem. In the end, what I'm looking at is a scattering problem of two particles. And if I can somehow visualize it on a diagram, today we call it as a Feynman diagram, and represent it like the incoming particle and the outgoing particle and the created photon, the energy particle, then I can somehow maybe able to capture. If I can also capture some of those integral calculations in those diagrams, then yeah, you can calculate it. And that's what Feynman did. So you see, physics is more than calculations. It's more than body of knowledge. It's the intuition. So stay with physics, and thank you.